All right, guys, this is going to be the recording for Thermal Energy 2.1. And so you can start by going to our homepage where everything lives. And when you go to this homepage, obviously we are starting chapter 2. What I told everyone yesterday and today, and I also sent an announcement out on Canvas, was that if you did not do the chapter 1 quiz that we ended the week with last week, or you want to fix your score, that link was sent in the announcements, and so you can do that. I'm going to start putting those in the gradebook though, so I didn't want to put those in before I kind of announced that because I didn't want to have everyone's grades drop, but I have to put it in now, so hopefully you got it to the score you want it to be in and you took it. So today we are focusing on that motion energy and how that energy can be transferred. And so we call that heat transfer. And you can see there is the assignment here for today. So you can click and open that up. And when you open that up, I'm going to have to scroll back to the top here. And so when you open this back up, you can see there is a picture. And when heat is transferred, there's 3 different kind of ways. There is convection, conduction, and radiation. And so what I did was I showed this YouTube video, and it kind of gives you some examples and goes through it. I'm not going to show it to you over this recording because these recordings don't pick up sound very well, but that is linked there for you to use to watch that. And then we kind of went through the meanings of them and talked about the different examples and things like that. And so conduction is what happens when heat is transferred by contact, and that usually happens through solids. And so the example up here would be C, how when you are cooking with a pot and that heat is transferred up the handle. Also, like if you're cooking pasta or something and you leave the metal spoon in the pot, that heat will transfer up the handle and you go to grab it and it's hot, burn yourself. And then convection is right here. And convection happens in liquid or gases, and that is when there's a cycle. When something heats up, it is attracted to the colder spot, so the heat will move to the cold, and once that heat gets cold again, it will drop back down, and so on, and it's an endless cycle. Heats up, cools down, drops back, and you can see these arrows here with this kind of endless motion. And then the last one is radiation, where heat is transferred without touching. And so that is this flame here. It is not touching the pot, but it is still transferring that heat to it in order to warm it up. And that's the same thing about like us putting our hands by a campfire, or if you have a reptile, like I have a bearded dragon and he's got the heat bulb, and that heat is transferred to his body, even though obviously the bulb's not touching him. That would be dangerous. And so that was that. And then we did a little demonstration. And so this demonstration video is in the slides. So if you click through your slides, the demonstration video is right here. And I'm not going to play this one either. You can watch that one on your own. Pause this video and watch that one because, like I said, the sound doesn't pick it up that well. But the idea, well, I guess I can play it without sound because you really just need to watch. This one is just a visual. So you're
Here we
watching
see
what happens.
an empty cup in a box with 2 thermometers. Both thermometers are at room.
Oopsie. Oh my goodness.
Here we see an empty cup in a box with 2 thermometers. Both thermometers are at room temperature, 22 degrees Celsius. Now let's lift the box and add hot water to the cup. Once we put the box back over the cup, no air escape. Now let's observe what happens to the temperatures of the water and air over time. We'll speed up the video to see the results faster. Let's take a closer look at our temperature data. The water started at 89.5.
And so the idea that they wanted you to observe is that obviously we poured hot water into this cup and that was the temperature starting, and my air was 22 degrees Celsius starting. And after a while, the heat escaped because we have a temperature of 66.4 degrees Celsius now. And then my air temperature went up. So that heat left the cup and was attracted to the colder air. And so that is why this kind of lost its heat, and then this was warming up. This will continue to lose its heat because there's no heat source. There's no burner or anything that it's on to keep it warm. And so that was kind of the idea. Oops, that is not your guesses. That was the idea that they wanted you to get. And then the last thing, well, not the last thing, but the main thing we did to kind of wrap it up was we opened the simulation, which you can see is hyperlinked right here. And so once you open that simulation, you're going to add one sample. And it doesn't matter what size the sample is, you're just going to add one. And then you're going to turn on the view kinetic energy toggle. And I will show you what that means. Going slow. Okay, so I'm going to add a sample, and I'm going to just add a medium sample. And what I'm going to do is I'm going to turn the view kinetic energy toggle on. And your goal right now is you need to change the kinetic energy of the sample. Right now you can see up here it's more of a low kinetic energy, and so you need to change it. And I'm not going to tell you how to change it. You will change it, and then you are going to decide what you think as far as the simulation. What do you guys notice about the kinetic energy? And I will tell you the hint, since I'm not telling you what I want you to do as far as changing the kinetic energy, but temperature and kinetic energy are related. So what is that relationship? Then for part 2, you'll reset the simulation based on what you did. And I didn't do anything, but I'll reset it. This button in the top corner is how you reset. And so you're going to add 2 samples this time and make sure they are the same size sample. So I'm going to add 2 medium samples. And so you are going to leave this off this time. You are not going to turn the kinetic energy toggle on because you're going to make a prediction and then test your prediction out. And so you want to make one sample move faster than the other and then make a prediction about that. So the warmer sample with faster molecules will have either a more or less kinetic energy. So you want to type which one you think it's going to have. So more or less than the colder sample with slower molecules. And then based on what you predicted here, you're going to go down here, and then you can turn on your kinetic energy toggle. So then you can turn this on to be able to see if you are right or wrong. So if I want one of them to be faster, and then I can see that it is faster. One thing I wanted to draw attention to when we did this is you can see, excuse me, the heat is starting at the bottom and working its way through. That heat is being transferred throughout the sample starting at the bottom. So then you will write if your prediction was correct. And then down here was just some practice. So I have a few samples, so A and B, C and D, and then E and F. And so the idea is that for each one, the temperature, I want you to tell me if it's hot or cold. And then for kinetic energy, I want you to tell me if it's high or low. So you'll look at each one of these samples, and so sample A, example, I know that that's hot. So I'm going to say hot temperature and then high kinetic energy. Sample B, I know that's low temperature, so that would mean it has a low kinetic energy, or I'm sorry, a cold temperature, low kinetic energy. Couple hints on these other two. When you have the lines behind, remember the longer lines mean it's moving faster. The shorter lines means it is moving slower. And then my two samples here, remember to find the average. You add all the numbers together and divide it by how many there are. So you would add these all together and divide it by 9. The lower number would be a lower temperature. Higher number would be a higher temperature. And so when you finish those, make sure you turn it in. Remember, these slides are down here for you with that demonstration, and that YouTube video is here as well to help you with the conduction, convection, and radiation.